In this lesson, we will discuss rule-based systems, one of the earliest forms of AI. We will cover how rule-based systems work, including the use of predefined rules and decision trees to make decisions and provide solutions. We will also discuss the strengths and limitations of rule-based systems, the fundamental concepts and technologies that form the basis of artificial intelligence. AI include: machine learning is a method of teaching computers to learn from data. It is a crucial component of AI and is used to create intelligent systems that can learn and improve their performance over time. There are different types of machine learning, such as supervised learning, unsupervised learning, and reinforcement learning, and various algorithms used in each type. Neural networks are a type of machine learning algorithm modeled after the human brain. They are composed of layers of interconnected nodes, called neurons, that process and transmit information. They are used for tasks such as image recognition, natural language processing, and decision-making. Computer vision is a field of AI that deals with the ability of computers to interpret and understand visual information from the world. This includes tasks such as image recognition, object detection, and image segmentation. Techniques and algorithms used in computer vision include convolutional neural networks, CNN, and deep learning. Natural language processing, NLP, is a field of AI that deals with the interaction between computers and human language. It is used to create systems that can understand, interpret, and generate human language. Techniques and algorithms used in NLP include tokenization, part-of-speech tagging, and sentiment analysis. Robotics is the branch of AI that deals with the design, construction, and operation of robots. Robotics is used to automate tasks and improve efficiency in industries such as manufacturing, transportation, and healthcare. Expert systems. An expert system is a computer program that simulates the problem-solving ability of a human expert in a specific domain. It uses knowledge-based techniques and rule-based systems that are able to provide solutions to problems and make decisions. Knowledge representation is the process of encoding information in a form that a computer can understand. It is the method by which AI systems can store and process information in a way that allows them to reason and make decisions. These are some of the fundamental concepts and technologies that form the basis of AI. However, the field is constantly evolving and new technologies and concepts are being developed. A rule-based system is a type of artificial intelligence AI system that uses predefined rules and decision trees to make decisions and provide solutions. These systems are based on the idea that knowledge can be represented in the form of a set of if-then statements or rules. The system uses these rules to reason about a problem and make a decision or provide a solution. The rule-based systems consist of a knowledge base, which is a collection of predefined rules, and an inference engine, which is responsible for applying the rules to a specific problem. The rules are written in a way that they can be understood and used by the inference engine to make decisions. The process of using a rule-based system to make a decision or provide a solution begins with the system identifying the problem it needs to solve. The system then uses the knowledge base to match the problem to a set of relevant rules. The inference engine then applies these rules to the problem, following a set of predetermined steps, such as using decision trees, to reach a conclusion or solution. For example, a rule-based system for diagnosing a medical condition might have a knowledge base containing rules such as if a patient has a fever and a cough, then they may have the flu. The system would use this rule, along with others, to make a diagnosis based on the patient's symptoms. The rule-based systems are simple to design and understand, and can be easily adapted to different domains. They are widely used in various fields such as medicine, finance, and engineering, but their use is limited by the fact that they can only provide solutions based on the rules that are predefined in the knowledge base. The knowledge base must be created and maintained by an expert in the field, and the system can only provide solutions within the scope of the rules that it has been programmed with. Strengths of rule-based systems include simplicity. Rule-based systems are simple to design and understand, making them easy to implement and maintain. They are based on a set of predefined rules, which can be easily understood and modified by domain experts. Adaptability. Rule-based systems can be easily adapted to different domains, such as medicine, finance, and engineering. By changing the rules, the system can be reprogrammed to work in different areas with minimal effort. Explanation. Rule-based systems can provide clear explanations for the decisions they make, as they use a set of predefined rules that can be easily traced and understood. Efficiency. Rule-based systems can process large amounts of data quickly, making them efficient in providing solutions to problems. Limitations of rule-based systems include limited knowledge. The knowledge base of a rule-based system is limited to the rules that have been predefined, so the system can only provide solutions based on the rules that it has been programmed with. Lack of flexibility. Rule-based systems are inflexible and can only provide solutions within the scope of the rules that have been predefined. They lack the ability to learn from new data, making them unable to adapt to new situations. Difficulty in handling uncertainty. Rule-based systems find it hard to handle uncertainty and exceptions, as they rely on predefined rules which may not cover all possible scenarios. Maintenance. Rule-based systems require constant maintenance, as the knowledge base must be updated and new rules must be added as the field evolves. Complexity. For more complex problems, rule-based systems can become hard to maintain and understand, as the number of rules can grow significantly. Overall, rule-based systems are useful in situations where a problem can be broken down into a set of clear and specific rules, but they are less suitable for more complex or dynamic problems where there is uncertainty or a need for learning and self-improvement.